Hello everyone, welcome back to another episode of Leetcode in Swift. Today we'll be looking at binary search. It's number 704 in Leetcode, and it says given an array of integers nums which is sorted in ascending order, an integer target write a function to search target in nums. If target exists, then return its index, otherwise return -1. You must write an algorithm in O log n runtime complexity. So let's look at an example, right? So target and 9 is at 4th index, and that's what's returned. So immediately we can see that it's in ascending order, which means it's sorted. And when it's sorted, you should and it's asking you to search for some element. You should always consider binary search because it's the most efficient search algorithm that you can use for searching elements in a sequence. So let's take a look at how to implement this algorithm and how it really works, right? So initially, what we want to do is, so binary search is basically when you split a sequence by half every time, and that's what yields us the O log n time complexity, right? And this is important because log n is actually the most efficient way of doing things. Mostly in coding interviews, this is what's noticed. Yeah, okay, so let's get started with the flow. So first, we want to split the array, right? So we want a pointer at the left side. So 0th index is left and 5th index is right. And now we have to find the middle element. So the middle element is basically left plus right divided by 2, and that's 2.5. So it'll round up to 3, and middle element will lie somewhere here with 5, right? And now then we would check if so this middle element is also called a pivot, because this is what we'll be calculating and this is what we'll be moving. So this is always calculated, right? So now we have to check if the element at pivot is equal to target. So our target given here was 9, right? So is 5 equal to 9? No. If it's not, then we check if target is less than this pivot element. Is target less than pivot element? No. That's cross number 2, the number 2 check. Then we check if target element is greater than or equal to the pivot element. No, we'd only check greater because we've already checked the equal to here. This is the lesser and this is the greater. So is target element greater than 9? If it is, what we can do is we can say left this index now is here, right? And then we run the loop again, and we always know that left is always less than or equal to right. This is the basis of our loop. And when in the second time we check if target element is equal to the left index or right index first, and it is, so we just return directly the index of this place. That's 4. That's it. I'm sure it's a little bit confusing, but I'm pretty sure when I code it up, it'll be much simpler. Let's look at that. Okay, let's quickly look at how to write the solution for this. So we need a left variable initialized to 0. We need a right variable initialized to the end of nums. That's nums.count -1. We already have our target in the params. So we know that we have to run the loop on the basis of if while left is less than or equal to right, and once it's greater, we break out of it, right? And now we have to find the pivot. So pivot is basically the middle element. So pivot equals to left plus right divided by 2, right? If nums of pivot, we now check if it's equal to target, then we just want to return the pivot index, right? Now in the else, if nums of pivot middle element is greater than target, when it's greater than target, when it's greater than target, what we want to do is, which mean now it means that our element is in the right side of the array, right? So we change the right pointer to be middle minus 1. Okay, and if these two fail, that means our element, target element, is on the left side of the array, which means on this side, right? So else left, we want to change the left pointer to be middle plus 1. So we check the other side of the array, and then we keep running this loop until we find a target element and we return something. But in case the target element is not there in the array, what do? It would break out of here, and then we would just simply return -1, like here. Okay, it says otherwise return 1. And that's it. That's the binary search solution. Let's give it a spin. Let's see what's this saying. Cannot find mid. Oh, it's pivot -1. Sorry. Okay, that runs. Binary search again. Submit it. Okay, that looks like it's pretty efficient with 92.51% of submissions online compared to. And yeah, that's the solution for binary search. Next, I'll be doing binary search in a rotated array, so stay tuned for that.